Hello, this packet will be on polynomials and it'll be starting on page 128. So let me share my screen and we'll get started here. Okay, this is the packet 128 from the algebra series. So we're going to be talking about a polynomial. So there's three types, and there's a monomial, a binomial, and a trinomial. And if you know anything about the English language, mono means one, bi means two, and tri means three. So a monomial has only one term. A binomial, like a bicycle, would have two terms. And a trinomial would have, like a tricycle, three terms. So the first part of the worksheet wants you to just determine if it's a monomial, a binomial, or a trinomial. So let me clear this and we'll scroll down and take a look at that. So number one, name each polynomial. So we are going to count the number of terms. We have a 5x and a minus 6. So how many terms is that? That is 2 terms. So that would be a binomial. Okay. Number 2, how many terms do you see there? Well, I see a 4x, I see a 6y, and I see a z. So that would be 3 terms equals a trinomial. Okay, what about number 3? Well, I see only one term. It's a negative y, or you could say it's a negative 1y. That's only one term. So that is equal to a monomial. Okay, so that's what you do on that part there. Go down a little further on the page. And it says, identify the terms in each polynomial. The first problem in each row is done as an example. So you have to figure out which things are terms. So if I go to the row 7, number 2 here, I have a 9d as one term, and I have a 6 as another term. So I would write 9d and 6. I think this is pretty straightforward. The next one in that row, I have a negative 3a squared and a 5a. So my answer would then be, I would write negative 3a squared and 5a. So you're going through and just finding all of the terms in those different polynomials. Hit clear. Go on from there to the next page, recognizing like terms. Like terms have to be exactly alike. So let's just look at an example here. 5 and negative 7 are alike because they're both constants, they're both numbers. X and Y are unlike. I'm looking here and I'm looking here. X and Y are unlike because they are different letters. Negative 3y and 4y right here are alike because they both end in a y. Negative r and s are unlike because they are two different letters. Okay, the next one. We have 5x squared and 2x squared. Notice how they both have x squareds in them, so they are alike. However, 4x squared and negative 2z are unlike. That would be the same also to say that 4x squared and let's say negative 2x, they are not alike either because one is an x squared and one is an x. So keep that in mind. Be careful on the last one here. 4a squared b, negative a squared b. Those are the same. They have an a squared and they have a b. But look at the ones that are unlike. A squared b and b squared a. Notice how a squared is not the same as a over here, and b is not the same as b squared over here. So these are unlike terms. So let's go and see how that's supposed to work here. We go to the first part here. You have to decide which one is the constant and which one is the variable part. Constant or the coefficient is another word for it. That's the fancy word, which they say right up here. Coefficient is the number that's directly in front of the variable part. So if we look at 3a here, the coefficient or the constant is 3, and the variable part is a. In the next row, -5 is the constant part, and the variable part is z. What about this one here? What's the coefficient? Okay, there's assumed to be a -1 or a 1 in front of any variable part. So that's assumed to have a -1 as your coefficient and a squared as your variable part. If you look at the one right to the left of it here, z squared, the coefficient is an imaginary 1 in front of the variable, and z squared is the variable part. So always remember that there's that 1, or if it's a negative sign, there's that -1 in front of the variable. It's assumed to be there, they just don't write it. Okay, so that's the top part there. The bottom of this page, you have to find polynomials that are exactly alike. And you have to be very careful on these because they have to be exactly the same. So I'm going to go down to row 7 here, and I'm going to look at the second one right here. So I have to find ones that are the same. So I have a 3rs. I have a -rs squared. So right away my brain is saying, well, s squared isn't the same as s, so they're not the same. Then I have a 3r squared, and I'm saying, well, r squared isn't the same as either one of the first two because they both have 1r, not 2. And the last one is 3rs squared. Well, I see that this -rs squared has an r and an s squared, and this 3rs squared has an r and an s squared. So those are the like terms. So you got to be very careful. Let's look at the one up here. So the first one is an a squared b. And the next one is a 2a squared b. Well, automatically, I see an a squared in both and a b in both. So those have to be the same. And the last one is a b squared a. That's different, right? That's not an a squared b. So we're going to have to look at each of those. Let's go on from there to adding polynomials. So you can look at that information later if you want. Let's just take a look at some of the problems. So the first one is done for you in the row. So let's look at the second one here. 5r plus 2r. So you add the coefficients. 5 plus 2, that would be 7. And then r just comes along. It's like your last name, Smith or Jones or whatever your last name is. The last name comes along with the individual. So if you have a sister named Sally, Sally Smith, and you're Bob, Bob Smith, you both have the same last name. So R is, so to speak, the last name. So you add the two numbers, 5 plus 2, and then R is their last name. Let's look at the next one. Oops, didn't want to do that. I'm going to clear all drawings. There we go. And 12s plus 2 or 7s. That would be, you add the 12 plus the 7, that would be 19, and then the s just comes along. So altogether you have 19 s's, so to speak. Let's look at this one here. 15r plus -4r. So if you have $15 in your pocket, but you spend 4 at the store, that's the negative side of it, you have how many left? 14, 13, 12, 11, right? 11, and then r comes along, so 11r. Okay, so that will be pretty easy to do. When you get to the next page, you're just getting longer equations to add. So in this case here, you have 4x squared plus 9 plus 4. So the like terms are what you add together. So the 4x, did I say x squared? I meant 4x. 4x is by itself because it's not like the 9, which doesn't have a letter, and it's not like the 4, which doesn't have a letter. So you add the two things that don't have the letter together. 9 plus 4 is 13. So the answer then would be 4x plus 13. You cannot add 4x to 13 because you don't have an x after the 13. So the answer here is going to just be 4x plus 13. Let's look at this one here. We have 6x squared plus 5x plus 3x. Well, which ones are like terms? Those are the ones that can be combined. Right, the 5x and the 3x here are able to be combined, but not the 6x squared. So the answer here is going to be 6x squared plus, and you can add the coefficients of the x's, 5 plus 3, 8x. So that's the answer to that one. And the page continues, you just get longer and longer equations. So let's take a look at one of the last ones on the page, number 11. We'll do this one right here. So we have 9m squared plus n plus 4m squared minus 3n. So we can only combine like terms. So don't let these parentheses throw you off. When you're adding terms, you can just kind of pretend they're not there. It's not going to be the same when we get to subtracting, but when you're adding, you can just kind of take away those parentheses. So we have a 9m squared and a 4m squared. Those are the same, so we can add 9 plus 4, 13. So we have a 13m squared. And then we have an n and a minus 3n. Be careful, it's a minus 3n. So they're both n's, so we can combine them. So what's the number in front of the first n? It's assumed to be a 1. So we're going to add 1n and minus 3n. So that's going to give us minus 2n, so minus 2n. So that's our answer for this one, 3m squared minus 2n. Okay, scroll down just a little bit here. They're just throwing in some geometry with the same type of things. Write the perimeter of each figure as a trinomial. Well, you're just going to, perimeter is adding all the way around, so you're going to add n plus 2m plus n plus 6m minus 1. So let me write that in there. So it's n plus 2m plus n plus 6m minus 1. And that'll give you your perimeter, but they want us to combine like terms. So if I'm combining like terms, I have I'm going to use red here. I have my m's are the same, and my n's are the same. And then I have this minus 1 by itself. So if I combine the n's, I would get 2n. If I combine the m's, I would get 2 plus 6, or 8m. And then I cannot combine the 1 because it doesn't have a letter, so I just have to say minus 1. So that's the answer to number 12, 2n plus 8m minus 1. So that's how you do those. And now as we come to subtracting polynomials, this is where we have to be careful a little bit. Let's just go down to some of the problems. You can look at those explanations later. So we have, it starts out easy, 5x minus 2x is 3x. So it's doing the same thing at first. 7z minus 2z, just take the 7 minus 2, 5z. So those are easy. Be careful when you get to something like this. It's minus a minus. So when you have minus a negative, it's really a positive, right? So it's really 6d. The two minuses cancel each other out. It's really 6d plus 2d. So the answer to that one would be 8d. So back to addition because of the two minus signs next to each other. So that one's just 8d. So be careful on those type. When you get here, now you, the second term is not in parentheses, so not much is really changing. You just have to combine like terms. So let's take a look at this one, for example. So we have a 12c minus 3d minus 7d. Well, the c is by itself, so 12c is going to be by itself. And then you have two d terms. You have a minus 3 and you have a minus 7. So if you have minus 3, you're going 3 to the left on the number line, and then you have to get 7 more negative. you're going to end up with minus 10, right? Minus 10D. So that's the answer to that one. Where it becomes a little tricky is starting with number 5. So here you have parentheses. We'll look at this one here. Here you have parentheses minus something in parentheses. So you have to change the sign because it's minus everything in parentheses. So you have to change the sign of everything in the second parentheses. And be careful, this is a good test question. So we have a minus 6x. And then we had a plus 2y, but we have to change the sign because we're minusing everything in parentheses. So minus 2y. And now we can combine like terms. We have 9x minus 6x, which is 3x. And then we have minus 2y and another minus 2y, which means minus 4y. So just be careful on those type. Okay, let's clear that. And I believe we are near the end here. You just got the same thing down here. It's just picturing it, and then you got some geometry. They're the same thing, they're subtraction. So let's look at number 9. They give you the perimeter. It's 8n squared plus 4n plus 5, right? That's the perimeter, minus, and then it's minus everything in parentheses, 2n squared plus n plus 2 plus 2n, I'm just taking every side, 2n squared plus 4n plus n squared plus 3. Okay, I'll make that all one long sentence there. So, and maybe I'll change it to red, easier to see. So I'm taking the perimeter, and I'm subtracting, so minus the other 3 sides to get the unknown side. So when you do this, first combine everything in parentheses that is alike, that's like terms, and then don't forget to change the sign because you have a minus sign right here and everything in parentheses here. So don't forget, once you've combined your like terms for all of this in parentheses, then change the sign of everything in parentheses. And then you can complete the problem. So that's kind of a little bit harder one. The 7 and 8, same thing. Your total is on the bottom here. It's 8a minus 2b, and then minus in parentheses 2a plus 3b to get the missing part right here. So it's just picturing what you were doing on the problems above it. I believe that is now the end of the packet, and it is. So have a good day. I'll see you next time. Bye.